In this example, we are going to be proving one of our compound angle formulas, the sine of x plus y, is true for when x is the angle pi over 6 and y is the angle pi over 6 as well. So we are going to be proving this formula to be true for those two x and y values. So whenever we are proving something, we always have to separate out my left side and my right side. So let's do that here. My left side is equal to sine of x plus y, and my right side is this piece here. So sine x cos y plus cos x sine y. There we are there. I'll move this guy out of the way here. Okay, so I'm going to choose to start with my left side here, and I am going to be plugging in my values for x, for this x here, and this y value there, for that y value there. So let's do it. So sine of my value of x is pi over 6 plus my value of y, which is also pi over 6. And now all I'm going to do is simplify the inside here. So I'm going to have to add these two fractions. Now the thing I have to have is a common denominator. And luckily for me, I do have a common denominator, so I can just add the tops. Well, pi plus pi is simply going to be 2 pi, and my denominators stay the same as 6. Well, this can reduce, can't it? We always have to be simplifying and cleaning things up as we go to make our work a little bit easier down the road. So that will actually reduce down to pi over 3. Make sure I get my colors right. Well, friends, this is one of my special angles, isn't it? Pi over 3. So I can actually use my special triangles here on one of my little planes to figure out the exact value of this, because I can put that in my calculator and get some crazy decimal, but that's not going to work out for me. I want to know the exact value. So I'm actually going to pop this right over here. So pi over 3 will be looking like that. Okay. This here is pi over 3. So as I'm drawing this to find the exact value, my first step was to draw. My second step was to connect the edge of that down to make a triangle, always to the x-axis only. And now I have to label my special triangle. Well, since this is a pi over 3, that means this is a 1, 2, root 3 triangle. And the 2's always are on the hypotenuse. And now I have to remember. And we got to remember that my middle angle gets my middle side length. So opposite the pi over 3 is the root 3. If you want to remember that the 3's are opposite, that could also be helpful. And which leaves this to be 1. Okay? My step 1 was to draw. My step 2 was to connect and label. And my step 3 was to now state the ratio that they've asked. And I would like sine of pi over 3. Well, we have to remember that sine of theta, of our angle, and deal with our y component. So it's y over r. So let's take a look at what's what. Well, this is my x component. It's my y component, and that is my r component. So that means sine of pi over 3 is going to be equal to my y, which is root 3, over my r, which is 2. So this sine of pi over 3 is in fact giving us an exact value of root 3 over 2. Okay, so that's my left side. Now I have to compare it to my right side to make sure this also equals an exact value of root 3 over 2. Now let's work through my right side. So what I'm going to do is I'm going to plug in my x's here, and I'm going to plug in my y's here. So that means this is going to be sine of pi over 6 times cos of pi over 6 plus cos of pi over 6 and sine of pi over 6. Now you know with the colors what pi over 6 comes from where. Well, my next step basically tells me that I need to find the exact value of sine of pi over 6 and cos of pi over 6, because then it's repeated here. I'm going to use this little plane down here to find the exact values. So I'm going to draw out pi over 6 over here. So pi over 6 is going to look something like that. Pi over 6 in here. My step 1 is to draw the arm. Step 2 is to connect it down to make my right triangle and label my sides. Well, because this is a pi over 6, that means, again, I'm dealing with a 1, 2 root 3. The 2 is always on the hypotenuse, and the smallest angle is opposite the smallest side. That's going to be a 1, leaving this to be root 3. Okay, so step 1 was to draw. Step 2, connect and label my sides. And now step 3 is to state the ratios asked. So I want both sine and cos of pi over 6. Well, sine, we know, is y over r. So that means sine of pi over 6. Well, let's remind us what's what. This guy here is my x. This is my y component. And this here is my r. So sine of pi over 6 is going to be my y, which here is 1, over my r, which is 2. That means anywhere that there was a sine of pi over 6, like here and here, that's going to equal an exact value of 1 over 2. And I bet if you put this in your calculator, with your calculator in radian mode, don't forget that radian mode, you would actually get 0.5, which is pretty cool. Okay, that's only sine of pi over 6. I still need cos. Now, let's just remember that cos of theta deals with my x component, so that's actually going to be x over r. So when I find my cos of pi over 6, okay, well, what's my x? Well, my x is root 3. It's going to be over my r of 2. Okay, that's pretty sweet. That means anything that had a sine of pi over 6, that would be this guy. And this guy is going to be that number. And anything that was cos of pi over 6, so this guy and that guy, is actually going to be that number. So I'm going to pop those in right into my formula. So sine of pi over 6 is 1 over 2. Cos of pi over 6 is root 3 over 2, plus cos of pi over 6 again, root 3 over 2, and sine of pi over 6 is 1 over 2. All right, so I'll highlight those again too. So that and that comes from here, and that comes from right there. Now I just have to clean this up and simplify. So I've got a fraction multiplied by a fraction, which just means I multiply the tops and I multiply the bottoms. 1 times root 3 is just root 3 over 2 times 2, which is 4, plus, we do the same thing here, multiply the tops, multiply the bottoms, giving me root 3 over 4. Now, I am adding two fractions, and the only way I'm allowed to do that is if I have a common denominator, and it looks like I do of 4. So I can just add the tops here. Well, root 3 plus another root 3 gives me 2 whole root 3s. It's going to be 2 root 3s all over 4. And now this can reduce, can't we? We always want to clean it up and simplify as much as possible. This will reduce down to 1. That reduces down to 2. We're going to end up with root 3 over 2. And wait a minute, check that out. It's the same. So that is exactly what we wanted here. We wanted to show that this formula, my left side and my right side, is equal. So to finish off any proof, therefore, left side equals right side. So there is a proof of this formula with 2 examples with angles.